So let's move on to section 7.3. Now, the values of the ratio. We've been talking in previous two sections, we've been talking about ratios and how ratios can describe a relationship between two things. And we can use different models to represent those ratios, whether it's a diagram or a picture or a double number line or a table. Well, the values of those ratios are quite important as well. And sometimes we can use those ratios as unit rates or multipliers. So let's see what I'm talking about here. So for example, we're going to be mixing an orange paint, and the ratio of red to yellow is going to be 3 to 5. And we can just make sense of that by saying there is less red, right, than yellow. So it's going to be yellower than red. Okay, so just to get a sense of what's going on. Now, let's take the multiple batches perspective, right? So let's say if we make a batch that is 3 cups of red and 5 cups of yellow, then could we create a number line where that is quite visible? Okay, so if we're going to say 3 cups of red and 5 cups of yellow. Okay. That's a particular recipe that you need to make 8 cups of this orange paint. But what if I wanted to figure out how much red I need for just 1 cup of yellow? So how much red I need for 1 cup of yellow, right? For every cup of yellow. Well, cups of yellow, I know that when I have 5 cups, I need 3 cups of red. But if I try to find how much I need for 1 cup, and that didn't quite, there we go. For 1 cup, I need to take 1/5 of that distance, right? Because it's 1/5 of 5. Okay. Now, how much red do I need? Well, I took 1/5 of 3. So it's 3 divided by 5. So it's 3/5. Right? So I need 3/5 cups of red for every cup of yellow. Similarly, we can look at 3 cups. Look at what happens if we want just 1 cup of red. Our original recipe said 3 cups, so we need to figure out what 1 cup would be, right? And that's 1/3 of the original recipe. So instead of 5, we would have 5/3 of the yellow paint. Remember in 7.1 we looked at. So notice we've created something that is relating each of the paint amounts to 1 cup of the other paint amount. That is really called the unit ratio. Okay, so every cup of for how many cups of red do you need for 1 cup of yellow? So we're able to show that, or to describe that as a unit ratio. So for example, number 3, I'm going to skip a little bit. If we were to describe 3/5 as a unit ratio, we would say we need 3/5 cups of red paint for every 1 cup of yellow paint. Okay, and conversely, for 5/3, we need 5/3 of yellow paint for each 1 cup of red paint. Okay, for each 1 cup of red paint. All right, so that's great. So that's a unit ratio, and it's very helpful as well. Now let's look at another way of interpreting these ratios. So if we draw a strip diagram to illustrate the quantities of red and yellow paint in a fixed ratio of 3 to 5. Okay, so this is going to be This is going to be red, yellow, okay, yellow. Now, if we have, back to this initial situation, 1 cup of yellow, right? 1 cup of yellow. Then how much are each one of these rectangles? If 5 of them need to be, you need to use 5 of them to make up 1, then each one of these would be a fifth, right? A fifth of the 1 cup of yellow. Well, if that's a fifth of 1 cup, then the red ones are also going to be a fifth of a cup. And how much do we have of red paint? 3/5 of a cup. All right. Do you see that? So whatever value we had for yellow, we're going to take 3/5 of that, right? 3/5 of that for the red. Now you can do exactly the same kind of thinking for the vice versa. So if this was instead 1 cup of red, then this would be 1/3, 1/3, 1/3. And then all of these would be 1/3 as well of the cup of red. So there would be 5/3 cups of yellow. Right? So if you have whatever distances, whatever the amount of red that you have, you need 5/3 of that for the yellow. So let's try to interpret that here. So 3/5 will then become that we need 3/5 as much of red paint as yellow paint. Or here we need 5/3 as much of yellow paint as red paint. Okay. So now we're able to interpret these 3 to 5 as a fraction, 3/5 or 5/3. And as that fraction, we're able to interpret that in 2 different ways. Either 3/5 of a cup compared to 1 cup, or 3/5 of the whatever amount of yellow paint. Okay. So make sure that those 2 different interpretations make sense. Now for 4a, given an amount of red paint, so you're given the red paint, how can you use the value of the ratio to find the corresponding amount of yellow paint? So if you know the amount of red paint, how much yellow paint do you need? All right, so amount of yellow paint equals how much of the amount of red paint? Well, if we look at these interpretations of our ratios 3 to 5 and 5 to 3, we need 3/5 as much red as yellow. So that's not going to fit into our statement here of how much yellow in terms of red. But we can also say that we need 5/3 as much yellow paint as red paint. So this does make sense that if we have whatever the amount of red paint, we need 5/3 of that in the amount of yellow paint. And I'm going to leave B for you to write out in a similar kind of fashion. Now, let's get to this beast, cross multiplying. Now, cross multiplying or butterfly method or whatever, the X method or whatever this method is called, and you remember it called from school, it's a trick. We can use, and I know that people would say, oh yeah, right, we have proportions, just cross multiply. That's the way to deal with proportions. Well, the follow-up question, if we're looking at conceptual understanding, would be why? Why does cross-multiplying work? I don't see any multiplication here. I see two ratios or two fractions that are said to be equal. I'm not even sure why they're equal, right, at the beginning, but I certainly don't know why I should be able to take them apart and cross-multiply and make that, and for that to be equal as well. That really doesn't make much sense. So instead, let's see if we can make sense of the problem and then try to see if that will help us understand this, quote, cross-multiplication. And maybe we can think about it in a slightly different way. So a recipe that serves 6 people calls for 2.5 cups of flour. How much flour will you need to serve 10 people? Okay, assuming that the ratio of people to cups of flour remains the same. So one familiar way to solve this problem is setting x be the number of cups of flour we need for 10 people and setting up this fraction x to 10. And then we know from the initial statement that 2.5 to 6 is going to be another ratio, and we're told that the ratio of people to cups of flour remains the same. So we're told about this equal sign. So next, we would probably not even think about it. We would say cross multiply. So we would get 6x equals 10 times 2.5. Great. And then we would solve for x by dividing by 6. So we'll need 4 1/6 cups of flour to serve 10 people. Okay. So the question here is, why does this happen? And more importantly, why does that happen? All right, so let's see if we can make sense of those. So what is the meaning of the fractions x to 10? Right, or x over 10? And what we can say is we can either interpret it as a unit ratio, or we can interpret it as a multiplier, just like we did before. So if x to 10, x was the number of cups of flour for 10 people. So x number of cups of flour, of flour for 10 people. Right? Can't we say that this is x tenths cups of flour per person? Right? X tenths cup of flour per person. Same thing here. We said 2.5 cups of flour for 6 people. And doesn't it make sense to say 2.5 sixths is cups of flour for 1 person? Now you might be saying, hey, this is not looking proper. We can't have fractions inside fractions. Not sure why exactly. It does make sense conceptually that is 2.5 cups of flour divided by 6 for 1 person. And now we're also told that the ratio of people to cups of flour remains the same. So we know that these two are equal. So x tenths is the same as 2.5 sixths. Okay, does that? I'm hoping that makes sense. If not, make sure you ask me a question during the Q&A. Now, so it makes sense that we will say x tenths equals to 2.5 sixths, but why in the world are we going to cross multiply? Why in the world would we cross multiply? Well, if we have x tenths cups of flour per person and 2.5 cups of flour per person, how are we going to be able to find the value of x tenths of x? Well, wouldn't it make sense if we had 2.5 sixths, right? That's cups of flour per person. How many people do we have? 10, right? We have 10 people. Shouldn't that give us the amount of flour for the 10 people? If this is per person times 10 people, that gives us cups of flour per person, cups of flour for 10 people, which is actually going to be the same value as this thing over here, which is going to be 4 1/6 if we simplify. Okay. Right? Do you see that? So that's not actually, there's really no reason for cross-multiplying. We can make sense of this problem without cross-multiplying. And there is really very little, in fact, it's less work to do it this way than to cross-multiply. All right, so now let's take a look at this. We should have set, if we could have set the equation up as 10/6, right? Equals x over 2 1/2. Now, what are the fractions 10/6 and x over 2 1/2? Well, 10/6 is 10 people in the new room and 6 people in the initial recipe, right? So we're trying to figure out 10/6 is going to be how much more is the relative size of the new party, of the new group, right? So if it's 1 4/6, or 1 2/3 the size of the old group, then don't you need to make 1 2/3 the amount of flour? Won't you need to use that much? So this is 1 2/3. So wouldn't you also need 1 2/3 the amounts of flour? So wouldn't you also be able to say that this 1 2/3 is the amount of flour you need for the new recipe divided by the old recipe, right? So that ratio should be 1 2/3. More importantly, you could say that 1 2/3 times 2 1/2 is going to be our value of x. So this is the flour for the original recipe. You need to multiply that by 1 2/3. You'll need a larger recipe, because you'll have a larger group. It makes sense that that's going to be why it's larger and why these two fractions are equal. Because as the number of people increases,